everyone, and welcome to the Solid State Watch. I'm Shannon Davis, the web editor for Solid State Technology, and now let's take a look at the top headlines you've been tracking from March 29th through April 3rd, 2014. Researchers at the University of Illinois at Urbana-Champaign have achieved new levels of performance for seed-free and substrate-free arrays of nanowires from class of materials called 3-5 directly on graphene. These compound semiconductors hold particular promise for applications involving light, such as solar cells or lasers. Led by Zuling Li, a professor of electrical and computer engineering at Illinois, the researchers presented the first report of a novel solar cell architecture based on a dense array of coaxial p-n junction indium gallium arsenide nanowires on indium arsenide stems grown directly on graphene, without any metal catalyst or lithographic patterning. Li's research group uses a method called van der Waals epitaxy to grow nanowires from the bottom up on a two-dimensional sheet, in this case graphene. Gases containing gallium, indium, and arsenic are pumped into a chamber where the graphene sits, prompting the nanowires to self-assemble, growing themselves into a dense carpet of vertical wires across the graphene surface. On Semiconductor this week announced the acquisition of Truesense Imaging Incorporated, a provider of high-performance image sensor devices addressing a wide range of industrial end markets. Under the terms of the agreement, ON Semiconductor will pay approximately $92 million in cash to acquire Truesense Imaging. ON Semiconductor said Truesense Imaging will be incorporated into its Application Products Group business group. By harnessing an electropolymerization process to produce aligned arrays of polymer nanofibers, researchers from Georgia Tech, University of Texas at Austin, and the Raytheon Company have developed a thermal interface material able to conduct heat 20 times better than the original polymer. The modified material can reliably operate at temperatures of up to 200 degrees Celsius. The material is fabricated on heat sinks and heat spreaders and adheres well to devices, potentially avoiding the reliability challenges caused by differential expansion in other thermally conducting materials. The research, which was supported by the National Science Foundation, was reported on March 30th in the advanced online publication of the journal Nature Nanotechnology. The new interface material is produced from a conjugated polymer in which aligned polymer chains and nanofibers facilitate the transfer of photons, but without the brittleness associated with crystalline structures. Formation of the nanofibers produces an amorphous material with thermal conductivity of up to 4.4 watts per meter Kelvin at room temperature. SEMATECH announced this week that Ronald Goldblatt, Vice President of Technical Strategy and Operations, has been appointed by the Board of Directors as Acting President and Chief Executive Officer. Dr. Goldblatt will replace Daniel Armbrust, who served as SEMATECH's President and CEO since November 2009. Prior to joining SEMATECH, Goldblatt spent 32 years at IBM Corporation. For more industry headlines during the week, be sure to follow us on Twitter or like us on Facebook. For Solid State Technology Magazine, I'm Shannon Davis. Thanks for watching and see you next week.